So in this presentation, we're going to touch on the benefits of a pneumatic mechanical retractable bridge, especially in the specific application for maritime shipping, how that is going to help with maritime shipping here in the Galveston area. We're also going to talk about the cost and efficiency benefits from a perspective of chemistry, how chemistry plays into this. And we're going to touch on how that helps with heightened corrosion resistance. How that's going to make the bridge last longer and how the maintenance costs on the bridge are going to be lower. And in this team, we had four members. We had Diego Garay, Brian Jong, Sebastian Jimenez, and Isaac Jeter. So Isaac, that was myself, kind of the team manager, kind of guiding a little bit, keeping people on schedule, things like that. Sebastian was the team facilitator, so kind of making sure that people were keeping up with their parts, doing their job, making sure everybody was staying on track and everything. Diego was the product manager, kind of inspecting, making sure, okay, looking for errors, looking for things that could be improved, looking for things like that. And Brian was the research facilitator, so he was kind of helping with the research, looking around, making sure the sources agreed, helping with citations and other things like that.
So the challenges we faced as a team were finding the time to meet and discuss about group projects. As for everyone, our schedules are very conflicting with one another. We also had trouble finding good sources for our research, and then one of our biggest challenges was agreeing on which thesis should be our main thesis because we had two really good options. But we resolved these problems by creating a group chat so we can communicate and set a time that and plan accordingly to meet. And we also use the university online library to find good sources, make sure they're peer reviewed and reliable, as well as just trying to keep the really good team environment. And if we ever have issues, we always would talk it out rather than argue. So our first proposal was just like solving the issue with the formation of rust on the hull of the USS Texas, and our solution was using zinc plates. The second proposal was solving the oil tank transportation on barges by making it removable instead of the built-in. The third one was similar to the first one, except it was just on the corrosion on the hull of the barges. The fourth proposal is using a hydroelectric power plant and setting it in between Pelican Island and Galveston Island to so we can generate electricity and be more eco-friendly. And then the fifth proposal was redesigning the mechanical structure for the Pelican Island Bridge, where instead of it lifting up, the bridge would retract under to make space for larger boats. But as a group, we decided to just go with the fifth proposal because it mainly applies to mechanical engineers, and everyone in the group wants to do mechanical engineering in the future as a career.
On this slide, you can kind of see some of the things we found out in the field, some of our findings. The first picture starting from the left, you can see the bridge kind of from a distance, and you can get a little bit of an idea of how close the bridge is to the water and how close the mechanism is also to the water. The second picture also is going to show you more how close the mechanism is to the water, and you can see a lot of the rust kind of on the other parts of the bridge to show just how important it is that it be far away from the water. And then the third picture shows you more of the mechanism itself, more of the mechanism on the bridge, and how much rust is also in there. If you look, down in that picture, you can see a lot of the rust on the mechanism and a lot of the things that are on there. And so, all of these things make it really important to get the mechanism off the water, get it higher up so that you can protect it from the rust easier. So here you can see you have the bridge. This is just the location of the bridge on the map. You can see Galveston Island and Pelican Island right above it. And that little yellow pin labeled bridge, that is where the bridge is at. It's just that little kind of small channel. And to the right of the bridge is the Gulf Copper Shipyard where they do a lot of maritime work. And you've got the the plant right across the channel where they do a lot of shipping. There's always ships coming in and out of there. And so it's really important to make this bridge more efficient for maritime shipping because there's just so much traffic and activity going all the time.
Okay, so here's some scientific evidence from literature. The first source, design and fabrication of a retractable bridge, gives us a better scientific view on retractable bridges. It tells us about the mechanism of retractable bridges and the advantages of, of the bridge. The sources talks about how the mechanical system allows the movement of the bridge to go underneath one side of the bridge, therefore allowing different sizes of water vessels to pass through without any hindrances. The second source, advantages and disadvantages of different types of movable bridges, discusses the many advantages of the retractable bridges that the drawbridge does not have. Some of these advantages that the retractable bridge has is the amount of wind load applied when the bridge is being retracted, as if the bridge is being retracted instead of being held upwards, it would face much less wind force. The third source, comparing cost and options for reconstructing the 12th and 27th Avenue Bridge over the Miami River, gives us an example of an average annual operating cost of 7 bascule bridges, which is another name for drawbridges, being $212,000. This leads to an average annual cost of one drawbridge being $32,000. This cost is just the average annual operation cost of the drawbridge, and it does not account for cost of repairs, which can also be very costly. The fourth source, preventing corrosions in steel bridges, gives us information about how if there is a corrosive agent on the metal before corrosion-resistant paint is applied, the paint can fail early and disastrously. The retractable bridge helps combat this problem as the piston is farther above the water, therefore limiting contact with the ocean and the marine life in the ocean. Areas to identify the problem, they would be civil engineering, mechanical engineering, chemical engineering, and ocean engineering. Civil engineers would look at the factors such as construction cost, longevity, and the ease of maintenance. Mechanical engineers would analyze factors like speed of the bridge, mechanical stress and energy requirements, and the overall operational efficiency. Chemical engineers would look at the corrosion resistance of the materials used on the bridge, and oceans engineers would evaluate how the bridge is able to withstand environmental conditions like ocean currents, tides, hurricanes, and marine life.
So how does corrosion affect the marine environment? Well, the first way that corrosion affects the marine environment relates to our project the most. The way it affects it is through structural damages that humans have built. The way that corrosion works, or that the process works, it reduces the strength of the metal. So as you can see in the pictures, you can see like holes, like, and then the material actually flaking off. And because of this, the over time the structure becomes weak and it's not usable anymore. So that's why you'll see like a lot of boats or bridges like abandoned if they've been corroded too much. The second way is oxygen depletion. So the process of corrosion takes oxygen from the seawater, and this obviously depletes the oxygen, which is not usable, which won't be able to be used by the fish anymore living in the ocean, causing them to live in a more stressful environment. And then the third way is pollution. Iron oxide materials are just thrown into the ocean because of this. And now you have like materials that are affecting the chemistry of the ocean, negatively affecting the marine life. So how should engineers handle this problem? So we said that engineers should brainstorm solutions that either prevent corrosion or minimize contact between the metal and the actual water itself. Um, our idea was to have a retractable bridge instead of a bascule bridge, which is the drawbridge seen on the Pelican Causeway. This bridge can be retracted during like severe weather storms or even just when it's not in use to minimize like contact between seawater and the metal. And you can see the on the GIF how the actual bridge works. And thank you for watching our presentation.